Okay, what we're going to be talking about is simplifying radicals. This is something you've probably done before, but we're going to kind of take it a little step farther. The two big things that we need to know when we're simplifying radicals, there's two properties. One, if I'm taking the nth root of a times b. Now, nth root could be square root, third root, fourth root, whatever root we're taking, this property is going to work. But if I have the product under my radical, what we're allowed to do is break this up into the product of two radicals. The other thing that we want to know is the nth root of something to the nth power is going to be just that something, so x. So an example of what this second one might look like would be something like, we know right now that the square root of 25 is 5, but how this turns into or comes into play down here is if we rewrite 25 as 5 squared, the square root of 5 squared is 5. So there's not a little number out here, but when we don't have a number there, that's the same thing as a 2 being there. So it's just understood that it's 2. It's a square root. So this number here, this 2 here are going to cancel each other out, and we're left with just 5. So where these things, what you've probably seen these things before, would be with something like this. If we just said the square root of 75. Now, that's not a perfect square. We don't know. We can't do it just like we did 25. So we have to do our little number trees, our factor trees. So we know that's 25 times 3. We know 25 is 5 times 5. That 3 just kind of drops down. And what we want to do right now is we've broken this down as far as we can. So we know 25 is the same thing as 5 times 3. Now what we want to do is we want to look for our root right here. What the root is, the index is what we call this number here. So there's nothing there, so we understand it to be a 2. So we want to look at our numbers down here and see if I can get a second power. Well, we know 5 times 5 is 5 squared, and then we have that 3. So we're taking the square root of 5 squared times 3, right? 5 squared times 3 is just another way to write 75. Now, I have a product. This is where that first property comes into play. I can rewrite this as the square root of 5 squared times the square root of 3. I can pull this apart into two separate problems. Now, the second property comes into play here. I have a square root of a square. That's just 5. I can't do anything with this, right? It's not a second power, so we're just going to keep it like that. So 5 radical 3 would be the simplified version of that. Now, it works with roots that are more than just a square root, right? We can find the third root of 16. So it's going to work the same way. We want to make our factor tree. So 8 times 2. 8 is 4 times 2. 4 is 2 times 2. Drop that 2 down, drop that 2 down. And so we know that 16 is really 2 times 2 times 2 times 2, which we could write as 2 to the 4th power. But we want to be able to use this property here. So we look for our index. It's a 3. So I want to try to write something to the 3rd power. So if I take these first 3 2's, I can rewrite 16 as 2 to the 3rd times 2. And the reason we want to do that is when we take our third root, we can split this up into two problems. 2 to the 3rd times the 3rd root of 2. I have a third root, 2 to the 3rd power. Those are going to cancel each other out, and we have a 2. There's no power here, so the power is 1. 1 and 3 don't cancel each other out, so we're going to have 2 times the 3rd root of 2. So one last example. Try to keep the video short. This is going to work if we have variables as well as numbers. So let's take the third root of 54, x to the 4th, y to the 3rd, z squared. So we are going to want to take advantage of the fact that we can break these things up like we did here. 2 things, pull it into 2 problems. 2 things, pull it into 2 problems. We're going to think of this as 4 little problems. We're not going to try to do it all at once. We're going to think about it as 4 little problems. So we're going to think of our 54. It's going to give us 27 and 2, 9 and 3, 3 and 3, drop that 3, drop that 2. We're trying to make powers of 3 to match our index up here. So we can make this as 3 to the third times 2. So when we go to take that root, the third root of 3 is 3. The third root of 2, well, we don't have a power of 3, so that's just going to stay third root of 2. So 3 times the third root of 2 is 54. Then we got to think about x to the fourth. Well, x to the fourth just means x times x times x times x. We're trying to make powers of 3, so I want to take 3 of those 4 and write it as x to the third times x. When we take the third root of x to the third times x, third root of x to the third is x. Third root of x is just the third root of x. If we look at y to the third, we have y times y times y. We're looking for powers of 3, so really we're just going back to where we started. The third root of y to the third is just going to be y. Then if we look at our z squared, that's just z times z, which is just z squared. And if we go to look, I have a 2 here, but a 3 here. They don't match. It's not going to cancel, so we can't do anything with it. We're left with just the third root of z squared. Now, what we're going to do is we're going to take these answers and we're going to smash them all together. Everything that's outside of a radical, we're going to put together. So 3xy stays on the outside. Everything inside the radical, 2x z squared, is going to go in the radical, and that's going to be our answer. So that's going to do it. Hopefully this helps you out a bit.